Hi there everybody. Is everybody on board with the visual metaphor here? This is the proverbial light at the end of the tunnel and our final project introduction. The good news about this assignment is that it's quite free form. There's a canned assignment in which you can define remoteness. Cache County would be the obvious choice because you already have a lot of data extracted for Cache County and you know where to get it from the Utah AGRC. You can define remoteness anywhere you want. If you want to work in another state, that's fine. Remoteness also can be defined many ways, right? Maybe you're a rock climber and you want to find the most remote or scenic place to do some rock climbing. Maybe you are a big fan of Dunkin' Donuts or can't stand them and need to be at least 10 miles away from any Dunkin' Donut location. Proximate to good snowmobiling, or you don't like the sound of snowmobiles, so you want to be at least 5 miles away from any known snowmobiling. You catch my drift. Cell phone coverage. All of this is data that you guys know how to work with and can get your hands on. The Utah AGRC is a great source. You've worked with DEMs before, so you can calculate slope. You can calculate things like aspect, which tell you which direction the slope is facing. This might help you define areas for great backcountry skiing, access to roads and trails, all data that you can get your hands on. All right, so here is the world is your oyster metaphor. So alternate analyses, of course. You absolutely can do what you want. You need to meet the minimum requirements, and I'll lay those out for you on the next slide. And just make sure that you're doing analyses, not just making maps. So even digitizing, that's fine if you want to digitize or create a map of a road trip or something like that. You still need to calculate some things for us, okay? Show us that you know how to calculate from a DEM or use intersect and buffer. Make sure you're doing some analysis between different data sets. So, minimum requirements. Wah, wah. You have to use both vector and raster data. So, like I said, maybe you want to digitize something, that's completely fine, but then make sure that you're bringing in raster data, like an elevation model, and calculating slope, aspect, distances, things like that. The vector data can just be data that you're extracting from the Utah AGRC and running buffers, intersecting, clipping, erasing, things just like in the YERT lab. So again, make sure you're calculating something. Calculate areas. You can use select by location, select by attribute, and then create a beautiful map, professional, effective, showing us your results and all the skills that you've learned this semester. And there are some basic requirements there too. And then you're going to write up your process something like lab instructions. They don't have to be that detailed, but here are some details about that. So you're going to submit two things, an explanation of your analysis and a formal map. You can produce more than one map if you want, that's fine. So in explaining your analysis, this is similar to lab instructions, so there's going to be some combination of steps and pictures, but the most important thing, I want you right at the beginning to lay out your specific definition, whether it's remoteness or whatever analysis you're setting out to do. We want to know right up front, at the top, first lines, what was the goal of your analysis. Then include some images that explain your process, and that don't need to be pictures of things like symbolizing or running basic tools or what order you stacked things in the table of contents. I'm talking about if you do a reclassify, for example, make sure that you're showing us that you set up the tool correctly. If you do a clip, show us that you're setting up the tool correctly, that your clip feature and your input features are set up correctly. Select by location would be a great screenshot. Show us what you're selecting from and then the select by location method, those kinds of things. You don't have to document every little tiny detail. And can you show us that you were checking yourself or evaluating yourself along the way for correctness? I ran slope and here's how I know it worked. My range of values is 0 to 70 and I ran it in degrees. That's a very reasonable set of output slope values for this area. Select by location. I was selecting within, and you can see here that my results are showing that the points were all selected within my other feature. Things like that. Okay, formal map. Bring us your best cartography. Spatial context, so an appropriate base map, and that means choosing the correct symbology over a base map. I've given you guys some feedback about the aerial images, the satellite photos, and how detailed they are. Don't use a solid fill polygon on top of a base map like that. You're just covering up all that detail. If you're going to use a solid fill on polygons or things like that, use a more graphic base map. Two basic things. Round your scale values when you're using a scale bar. Remove base map credits. The one that's missing here is units for values. If you put elevation, legend on your map, for example, make sure you include units for the values always, always. And then along with hierarchy, and I'm talking about text sizes and boldness, whether you put frames around different elements on the map, make sure that your alignments are nice and tight. These are the things that we're going to be looking for on the final map. Okay, complexity. There will be a bit of the grade that's just reserved for complexity of analysis. So I want you guys to understand this isn't like you get 100% if you turn something in and then I'm going to deduct points for little things that you've missed. If you meet those minimum requirements using vector and raster data, demonstrating your MAD skills, and make a beautiful map, meeting all those things, you can expect to earn 85% on the final project. I know this isn't Utah typical, but that's how we're going into this. If you want to receive 100% and do better than a B, and a B is a great grade, you need to go after a few things. You need to download some additional data. Don't use just the canned data that we give you in the zipped data folder. Go find something new to work with. Introduce a new tool. Go find something new that you've never done before, kind of like the Freestyle Lab. Have some fun with this. If you digitize, that's fine, but then also run some vector tools on top of what you're digitizing. Digitize something and then also bring in some vector data that you can buffer, clip, intersect, etc. The presentation, you can do a great job and remove base map credits and have round values on your scale bar, but having looked at these maps, I think you guys can understand that there is a step up that you can do where you just dial everything in very carefully. And so it's these kinds of things that are going to elevate you from a solid score of a B up into the 90 to 100% category. Okay? So here are some hints. Use Google. If you're not sure how to do a tool or what tool to use or what it's called, Google something like ArcMap. How do I cut a polygon in half? Or how do I, just put it in English, and I'll bet you'll find something that will help you explain. And when I say put it in English, I mean don't try and use GIS-y terms if you don't know what they are. Just go ahead and describe it in a very narrative way. Use the tool help in ARC. There's a tool help button at the bottom of every tool. It opens a window on the side and it gives you explanations of all the different inputs. Go to the Utah AGRC to find your data. Take notes as you go. This is a really good idea. It's going to make doing that write-up super fast and easy. It's really easy to delete the stuff that you didn't end up doing or using, but going back and recreating is going to take more work. And then data credits. Keep track. When you pull stuff, record the data credits, because I will be looking to see that you're not just giving credit to, Wild 1800 or Utah State University or me or Doug. So make sure you're giving the appropriate data credits as you find different sources. And don't procrastinate getting started. This thing is due April 23rd. It's a Tuesday. It's due before midnight. This lab is going to require troubleshooting. It's going to require you working through obstacles and failures. You're not going to have instructions. You're going to have to do some research and explore and dig, and you're going to try things and they're not going to work. Your original idea is going to be great, and then you're going to realize you don't have the data to make it happen. So start right away. At least make sure you've got data that you want to work with. Here's the calendar. Monday the 8th is when I'm recording this. We've got lab this week, 3 of them. They're going to be 6 hours of open work time. Next week, we've got 3 different lab sessions. You're welcome to attend any or all of them, but it's just going to be open work time. And then this thing is due 2 weeks from tomorrow. It's worth 1.5 labs. It's 150 points. I will be docking ruthlessly for late. This is a time management issue. So if you get your lab in at 12:01 on the 23rd, you will immediately be docked 10%. That is not just to be a jerk, but I've got to manage my time as well. I've got 200 labs coming in. So manage your time carefully. 12:01 less 10%. If you turn it in the next day after midnight, you're going to lose 20% right off the top. And I will not accept it after midnight on Friday the 26th. You will receive no credit. Now, this happens all the time. I get my instructions emailed back to me or submitted back to me. Be very careful when you're naming things that you don't submit if you name your thing final lab instructions, you may end up submitting the final lab instructions back to me and you will receive 0 credit, okay? Be very careful. Same with MXD documents. Do not submit a map package or a map document, an MXD document. You have to export your maps to PDF and submit them in that flattened compressed format. You will just receive 0 credit. Okay, so be very, very careful. I don't want to have to do that to anybody. But this is all about file management, data management, and time management. Okay? All right, if you have any questions, please email. Show up for labs these times. I will be very hesitant to provide help to people via email or to meet with people outside of class when we have these 12 hours available for help. So please show up in lab. Come with questions. We're going to handle it somewhat democratically where we're just going to put names on a board and I'll just, between Doug and Dylan and I, will just cycle through and make sure everyone's getting help, okay? All right, any questions, let me know and see you in class.